Welcome to our second installment of the Database Tycoon Summer Camp. So for those of you who are just tuning in for your first summer camp session, this is a 9-week free crash course in data fundamentals where we have different guest speakers doing these weekly workshops each week. And today we have Adrian from DLT. So Adrian will be walking us through what DLT is and how we can implement DLT for data help in our everyday lives. And it appears that there's a mix of people here, some data natives, some just curious, and this is just the perfect, audience for a session like this. So Adrian will be giving the session and a presentation. And Adrian, it's up to you whether you want to answer questions in the middle of it or not. But as general rule of thumb, I've just instructed people to leave questions in the chat. So you can answer them as they come in, or you can answer them at the end of the session, up to you. And yeah, if you answer, those of you who you attended the last session last week, the SQL 101 with Selena Wong. This will be your second session. And so if you attend 3 sessions, any given sessions, they don't have to all be in a row, of our summer camp, you'll receive a certification of completion, including a certification you can put on your LinkedIn profile. Yeah, so I'll be attending the recording, recording the attendance. And also there will be a recording of this session that will be posted to YouTube. So everybody who has signed up for the summer camp sessions will receive a link to the video link, so you can always refer back to it. And with that being said, Stephen, do you have anything else to add before we kick things off?
No, I think let's go ahead.
Hey, right, Adrian, the floor is all yours.
All right, thank you, Chloe. So I apologize in advance. I woke up with a sore throat, so I might be a little raspy and drinking often, but here I go. I'm not sure how long this presentation will take. I will try to go quickly. Let me share my screen. Feel free to ask in the chat if anything comes up. So because you titled this cost saving in data engineering, I gave it also a cost saving theme. I recycled part of this presentation and part of it is new. So it's like also kind of the latest stuff. Okay, so a little bit about myself. I come from Eastern Europe. I studied economics originally, and I started in the data field in 2012. So that's quite a while ago. I worked for 5 years in startups in Berlin. I did all kinds of data stacks, Python, Ruby, Postgres, Redshift, MySQL, all the wild stuff. And in 2017, I switched to freelancing because I wanted to do more work without dealing with, let's say, company culture and, typical company timelines. And finally, after a few years of freelancing, I was very much over building data warehouses. So I thought, okay, I could build a dev tool to kind of give back. I felt like, getting into this career was really a huge opportunity for me. And I also kind of wanted to give back to the community. Especially as a freelancer, I have to say, I felt like the community was giving me a lot. So I started this dev tool called DLT, which aims to solve ingestion for data engineers, which is what I was doing, who are building data stacks. So what is the problem that we're solving? That problem is that data engineering is difficult. There are many tools. Data is messy. The data that you get, for example, from API is going to be nested JSON with many-to-many keys. No structure, file dumps with unversioned files, unstructured folders, duplicates. And whenever you build your own reliable extract and load solution, that takes time. It could take years if you want to do everything perfectly. So when you want to solve this kind of problem, you'd go to Google and you'd get no good results. Commercial tools will be very expensive, limited in customization. So eventually you'll end up adding some kind of endpoint, and then you end up building the client for an API anyway. Or they have black boxes. You don't really know how data is being transformed, and you can't replicate the same outcome. You might have gotchas in billing. If you use open source tools, before DLT, open source tooling was quite complicated because nobody really built it for the data practitioner. And when you wanted to migrate away, you'd say, okay, maybe I can start with something like Fivetran, but then I migrate to something cheap. Well, migration is expensive. So you'd think, okay, I'll build my own thing. And I've spoken in the past why you shouldn't do that. I mean, of course, you'll build your own thing, but the reality is that due to time constraints, you'll end up doing not the best engineering work, and you'll end up spending lots of time maintaining that. It won't be fun. So, some people think, it's just like, loading with pandas, but they don't see the complexity. Besides, if you were just to look at pandas, what else you need? You need atomicity, you need idempotency, you need memory management, you need incremental extract and loading, which means you need state, you need to capture that, you need to inject it back into the extractor. You need materializations like slowly changing dimension or merges. What else do you need? You need basically to standardize the way that you extract your data. You need to make it efficient and scalable with parallelism and async. You need schemas because whether you realize or you don't, you're using schemas. You might be using them explicitly or implicitly. It's called schema on read in that case. You typically need a normalization engine to convert, for example, your timestamps to proper timestamps types. And you need all kinds of things for resilience. So for example, what could happen is you're downloading a huge list of items doing, I don't know, 1 million API calls, and it breaks close to finish, and then your job restarts. That's horrible. So you want to keep track of all these things. You want to be able to retry. You want to be able to, if you have a network error, not have to resume the whole job. Finally, schema changes. So you want schema evolution with notifications. You want data contracts. You want governance because you fundamentally want lineage from ingestion all the way to usage. If you don't have it, it's going to be very hard to maintain your data pipeline. So in the end, it's not as easy as just using pandas. You need a much better tool that actually handles a lot more complexity. So this is why we built, this is how we built DLT. And we wanted it to be as easy as pandas, but handling all these necessary cases. So one of the most important things about DLT is the fact that the world changes, and with it data changes, and your schema changes, and because of this, typically pipelines break, which lead to lots of maintenance, lots of downtime. And fundamentally, you want to avoid that. You want to be able to just kind of load the data. Now that you have it in a place with explicit schema, you can look at it, you can decide what you're going to use. So this is why DLT will just take just about any data structure, figure out its schema, and then basically break it into tables and put it in a relational structure that you can explore. I can tell you an example. If you don't do that, what could happen? In one project where I was working, when we aggregated point of sale data from multiple stores across multiple countries, we found that in the old reporting that they were doing when they were parsing some nested XML, one of the fields had multiple types. So it could either be a dictionary or it could be a list of dictionaries. And because of this, they were basically calculating returns incorrectly. So with an explicit schema, you don't have those kinds of problems. So as I was mentioning, sometimes you have nested structures. So DLT will generate flat relational tables with join keys, so you can join your data back. DLT is easy to install, it's easy to use, and it's Pythonic. It pretty much contains all the best practices of people who have worked before with data. So schema, evolution, data contracts, incremental loading, and performance management. It has an ecosystem. And now I'm going to do a brief deep dive. So just some screenshots of code to demonstrate how it works. So this is a crypto case. It's giving example of calling some data from doing an API call to get a list of tokens, and then doing a second API call to get detailed information about these tokens, prices, and related exchanges on each token, whatever that means. I'm not into crypto, sorry. And finally, we show how that works kind of together in a DLT source. So basically, a resource generates a table, a transformer also generates a table. We use decorators to kind of configure how everything works, so like incremental loading, things like that. And we group resources under a source so we can run them together. Finally, we pass those generators to the pipeline to load them. So the pipeline basically can just load just about anything to a destination, whether that's just a JSON, Pandas data frame, or your DLT source. DLT resource will yield a list of tokens in this case. So basically you want your resources to yield data. Yielding data helps you manage memory because instead of collecting all your data in a list, which puts it in memory, you return one by one the items from a list, for example, from API calls. And this way we can consume that item by item and not load everything into memory. Then this transformer is also yielding a nested list of JSONs. And this source is yielding the resources. This is how it looks like in actual code. So you can see the first resource named coin list. Then the transformer takes data from this coin list and we group them in a source. And then with the pipeline, we just load them. This is how it would look like because you get your nested data unpacked to tables. And this is what the tables would look like. So for example, if you have date time, it gets converted to proper type date time, not like JSON string date time. Okay, so how can you save by using DLT Hub? There are three ways. You can easily use it to save lots of money. One of it is, just use it instead of expensive solutions. So DLT was built as a dev tool, which means like even though it doesn't give you out of the box all the possible connectors that you might want, it will still be very easy to build yourself whatever you need, especially with AI acceleration. So here I have a case from Martin Salo. He was CTO at a company called Yummy.eu, which was doing some kind of food box delivery. And what happened with them was he was just synchronizing databases with Fivetran on 15-minute intervals incrementally. And he added a new table to a database, forgot that he has Fivetran running, and at the end of the month, he found a huge bill. This table basically ended up being copied on a 15-minute interval, full load, and it cost a lot of money because it was a very tall table with lots of records. So this is just a default setting for vendors like Fivetran. If you will look why people are complaining, this is one of the main reasons. This is one of the reasons. Essentially, there are gotchas in pricing model where they kind of like, it's industry standards, basically. They try to make more. So when they switched to DLT, they achieved 182 times cost reduction and 10 times the speed. Sorry. In the meantime, we also added a fast SQL backend that's 15 to 30 times faster. So this actually makes the SQL copy 3 to 5 times cheaper than Fivetran in this case. In another case, we replaced a segment And we actually used segment in the beginning, but what happened was we started getting some users, so we use it for telemetry. We started getting some users that were very active, and because of this, it ended up costing us a lot. So we hurried and migrated to DLT. And when we did, we found that our solution was 100 times cheaper. Essentially, it was just some cloud functions with pub/sub and DLT to insert data. And you can find these templates actually on our blog. There are also multiple blog posts with different types of setups that other users do. Another way to save with DLT is using Iceberg. So how do you save with Iceberg? Fundamentally, one of the problems with data warehouses is that they're not really meant for general computation. They're very expensive. They're meant for fast aggregation. So they're great for reporting, but for ETL jobs, they're overpriced, you could say. So here we have a case of a user, Tactile. You can find this video on YouTube. It's called Scalable Lakehouse Architecture with Iceberg and Polaris. So what they did there, they are a fintech. They're called Tactile, and they were onboarding a client that was 30xing their data. And because of this, their Snowflake bill was raising into 1 million territory. So of course, in that case, you want to make sure that your operations are cost effective. And they looked into the way that they were doing loading. They were basically getting events into a buffer, something like pub/sub, for example. I don't know what they used on AWS. Then some lambdas would basically read that data and insert it into Snowflake. This scales very well because you have lambdas which scale. But the problem is that Snowflake was doing the compute over the data. So when you insert and merge data, for example, you pay a markup for the compute through Snowflake. So they switched to loading via DLT and Iceberg, and they achieved a 75% cost reduction. Another way to save with DLT is to be more efficient with AI native. So here I will show you some recent work that we've been doing. So first of all, we were thinking, should we even approach this topic? People don't generally like vibe coding, and I understand why. And I would say the biggest problem is that you get a lot of code very fast, and then it's your problem to review it and make sure that it works well when you didn't write it. So that's going to be hard. So what we did actually, we thought, okay, we built something we call this REST API source, which is essentially just a Python dictionary that allows you to configure declaratively how to call an API. This is much more readable and easy to review than actual code. So basically, we thought, how can we get GPT to fill in this template, you could call it? You could ask GPT to do it, and it might know. You can ask Cursor with an agentic model, and then you don't need to copy paste, and it works much better. You could add documentations from the source or from DLT, and that might work a little better. Or you could do something that is now called context engineering, where you basically write improved documentation to manage the context of the LLM to better be able to do the task that you needed to do. So for this, we try to troubleshoot the process and understand exactly what isn't working when something is not working. Is it we cannot understand the API? Is it that we don't have a good context to turn the API into a pipeline? So we broke down the process into two steps. One was extracting the API details, and the second was writing the pipeline. So we could actually verify what was or what wasn't working. Then we started testing it with different sources of information, and we found that you can achieve some results, but poor without docs. So basically, if you actually ask LLMs to search online or to curl APIs, they will sometimes try to brute force APIs, and they will sometimes succeed, or they will ask for a little bit of data. If something works, they can go from there. Of course, it's much better when you add documentation. And one of the best things you could do is actually give it code, because when you add code as information, as documentation, you're actually showing LLM more. So like how responses might be handled, or, you're actually showing it kind of like code that that it needs to do. So then we basically asked our team to try this process and to create improved rules or improved context, improved documentation. And we created something called cursor rules that you can deploy with this DLT AI setup cursor command. So if you're using cursor IDE, if you're not using cursor IDE, you can still use the same rules. Cursor is nice though. It has access to models, and we will make it IDE independent soon. So this is the human in the loop workflow powered by Cursor. First, you init rules, and this scaffolds a project. Then you add context like documentation, and you prompt. Then you go into what people call YOLO mode, where you basically just pass the error back into the chat and don't really say anything. You just hit enter and hope for the best. And you basically do this until your code runs. It usually runs within 5 to 7 steps. If it doesn't, try again. Finally, when it runs, you should review and test it. And here, actually, we're preparing a really cool product. I will show you after the presentation. Right now, you can basically easily spin up a Streamlit app. It's not great, but for example, if you're loading to DuckDB or if you're loading to local files, this app gives you a client to be able to interact with these things. So yeah, it usually works. So we actually also created a YouTube video for it. So you can search for this title, for example. And here you will find a 1-hour course where a colleague of mine is demonstrating a couple of cases, and he's explaining how to do it, basically. So stay tuned for DLT Hub. Basically, I will show you a few things on our documentation.
Hey, Adrian, I just have a quick question about some of what you were just showing there.
Yeah.
So are you saying you're actually planning to build into the CLI a cursor command so that it'll, like, from within your cursor terminal, you'll be able to initiate a project?
So let me show you what we're playing with right now. You can already try it. It's, you could call it preview. It's very early. This is not where we're going. This is just like the first step. But essentially, there is something called Marimo Notebook. And you can use this as a local client. You can spin this up. You can also deploy it. But essentially, as you can see here, we created a database client that you can use, and it gives you a little bit more flexibility. And we're essentially thinking to bring this context into this notebook, which you can then just launch from CLI and use it there.
Very cool. Yeah, thank you for showing.
All right, so I had no idea how long my presentation would take. Does anyone have any questions? That was it pretty much.
Can you maybe just give a quick update about DLT Hub, like the cloud offering that you're working on?
Sure. So I would say the way you can think about what's coming next is more of what you're seeing here. So essentially, we're thinking our next step, what we will build is a command and control app. So basically this local app that you can see here with way more widgets that allow you to build faster or interact with content faster, such as we are preparing something pretty exciting for next week. I call it scaffolds. But essentially, as I was telling you right now, we're playing with context engineering. So context engineering means giving the right information to an LLM to be able to let it do the work that you want it to do. So what we're doing is collecting a lot of information. I call it scaffolds. It's essentially, let's say, LLM instructions generated from documentation that you can find online. So like instead of you reading the documentation, we extract the essential information, like I was talking about earlier, and we generate context for your LLM. So basically what's coming next is this app tied together with LLM context, and eventually we will build a runtime for it and a way to go multiplayer. Does this make sense?
Yeah, no, it sounds exciting. I'll be looking for the announcements for that coming up. I actually saw we did just have a question submitted in the chat. Somebody asked, what are the biggest misconceptions teams have when trying to move from legacy ETL platforms to a DLT-based pipeline? Maybe to ask it in a slightly different way, like what advice would you have for teams who are looking into this migration?
So I would say the migration is way easier than you think. This is what teams are telling us. You won't use the 12 weeks or the 4 weeks or however long you think it will take. Usually the barrier is emotional. It's trying. Once you actually make a plan and you decide to get started, you might find that you manage to migrate anywhere between a pipeline per hour or a pipeline per day, depending on like how much you're building on it. What actually helps a lot is if you have any pre-existing information. So for example, if you are converting your legacy pipelines, you might just put them as information in cursor, and then the LLM will do the conversion for you.
Oscar?
Hello, thank you for that. You had very information-dense slides, and your meme game is on point. But I was wondering if you would share your slides with us so that I can share them with my colleagues.
Sure, I can do that right now, actually.
Very good. Thank you so much.
Anyone else in the crowd have any questions they'd like to jump in with? Feel free to either unmute or drop it in the chat if you prefer. In the meantime, I actually do have one more question, Adrian. So I thought that was a very good walkthrough of DLT, and I like the approach you're taking with the product where you're making it simple to work with the Python. It's just a package you can install. But you know, for the others on the call who maybe use other tools, I know you talked about price a bit, but what are some of the reasons we should consider DLT? Like why DLT?
So the thing is, I've been doing lots of data engineering, and there are generally, let's say, two problems that I see appear a lot. One of them is if you're hoping to just buy connectors and solve the problem with that, it's not going to work out. So it might for some time, but eventually there's going to be a requirement, a new API, a new tool, a new endpoint, and you're going to have to do the work anyway. And now you have two problems, your pipeline and the vendor's pipeline. So you might as well just rip off the Band-Aid and start with the custom thing. DLT is not just your custom code that will break all the time. DLT adds a lot of resilience, so you can just use kind of like commercial grade engineering right off the shelf in minutes. Another reason I would say the second problem, basically I was doing a lot of build and hire projects where you build out a data warehouse and you hire a team that will do the data team work essentially. And the problem that I had there was when I was using my own custom code, it was very hard to onboard others because I had no documentation or my documentation was garbage. Or it was just basically too hard, not the right abstraction level for analyst colleagues, right? So while they knew how to do Python, they would eventually start using pandas because it was easier to use, and then they would get stuck maintaining a pipeline. So basically, the reason why DLT is also because your entire team can use it. So it's very easy to, transfer when you go on vacation, responsibility, or onboard a new team member.
Cool. Definitely makes sense. And it ties back to the beginning of your slides where you mentioned, if you're going to use pandas, you're probably not thinking about all these other things that need to be built. Great. Okay. I saw another question just come in. Just give me a second to try to find that.
In the meantime, I can answer this other question maybe.
Oh yeah, if you see it, go ahead.
So Airbyte, Airflow, DLT. So I think most of our people are running DLT on Airflow. We designed DLT so it runs on Airflow. There's even a Airflow deployment which unpacks the internal DAG of DLT into Airflow tasks, and then you can visualize it in Airflow. So we recommend, run it on Airflow if you're using Airflow. Airbyte, they're competitors, yes. I would say not the same audience, but the same use case. And also, let's say, competition for attention, because we do product-led growth. So we basically invest most of our effort in the product and talking about the product. We don't do a lot of marketing, which means, we will not capture as much attention, let's say. And sometimes we compete for that.
Awesome. And then, yeah, I saw another question come in. Making DLT easy to use and able to handle changing data across different databases seems really tough. What were some of the hardest design choices you had to make to keep that simple and flexible?
Yeah, so this is something that people complain about all the time. So sometimes you have null columns. Okay, this I would say is not a SQL problem. It's an API problem. So when you ingest JSON into the database, JSON is weakly typed. It only supports numeric and string types. It doesn't have date times, for example. So you need to actually infer the schema from the JSON to be able to load this data. But if you have a column or CSVs or whatever, but if you have a column that is null, the problem is null doesn't have any information to infer the type from. So basically we have to drop this column because otherwise we would have to prompt you for the type or do some kind of like random thing and then evolve it from there. So yeah, basically lots of people complain that, hey, my null column didn't load. We tell them that's too bad, but if you want this to work, this is how it's gonna work.
And so for all of your database connectors and warehouse connectors, I know you said you have a hub where you maintain some code. What's your process like for updating those? Are you working with like customers who use those databases and getting their feedback?
So we have tests running daily. Tests don't always say everything. So if you have a problem, report it and we will fix it. So basically, this is also part of the reason why we're not currently hosting lots of connectors. We don't want the maintenance burden. But we're basically working on making it really, really easy to get the connector that you need.
Great. Okay. All right. Looks like that's all the questions that have been submitted in. Does anybody else have anything to ask while we're all here?
If nothing else comes up, you could use the last 20 minutes to just go on our GitHub, and there you'll find a repository called DLT demos with some collab notebooks, and you could either dive right in. I'm the kind of person that likes to jump into code, just try things. Or you could, set yourself another 40 minutes aside, and I think within 1 hour you'll be able to build a REST API source or anything like that. We also have a repository actually with just education, with hours of courses that you can take.
I'll say that for me and some of the people on my team, we've started taking the certifications that the team has offered, and they're really helpful for getting started. They're just as loaded with memes as Adrian's presentations are, so they're fun to follow along.
Our team also uses those courses actually for onboarding. So both the developers and other roles go through this course. They all get certified, gets everyone on the same page.
Nice. So we're taking the same course as your engineers, basically.
Mhm.
So maybe I'll end it, if there's no other questions, I'll end with sort of a light question, which is what's something in the data space that you're excited about in the next, I don't know, 3 to 6 months?
Honestly, I know everyone's saying this, but AI, it's really exciting. Basically, it can do a crazy amount of stuff. It's only getting better. And we are basically like everyone, lots of people are talking about it, but I feel like not enough people are taking steps. It's inevitable that we're going there. What I'm noticing is also that there is a shift in mentality in people where I know you guys in the US, you're different. You guys are, like breaking ground. In Europe, we're a little bit behind. But I would say even in Europe, I'm starting to see maybe at meetups or conferences, 50% of people accepting to work with AI, which is a lot more than in the beginning of the year when everyone was hating on vibe coding. So what's exciting me is that AI is not going to be just like a feature that people are going to sell or a product. It's going to be a baseline necessity. If your product will not offer AI enhanced workflows, it will just die out. So I'm very excited basically to play with these kinds of things and build really like good AI assisted software that makes you an accelerated problem solver essentially. So, just trying to make as effective and as easy the work that we're doing. So we're stuck doing the, let's say, very custom, very artisanal, or the relationship work.
Cool. Yeah. No, I mean, I think I can speak for a lot of data engineers when I say that if I never had to take another page of documentation and manually rewrite it to code, it'll be, too soon. So I'm excited as well to see what the future of AI, this vibe coding revolution, so to speak, can lead to in the world.
All right. So thank you guys so much. That was an incredible session, Adrian. Thank you so much. It's funny because we are taking the course. So to have this call, we had a call about our course right before this. So to have the call right after was so helpful. And everybody really enjoyed it. So thank you guys all for attending. So in the next couple of days, we will have the link to the recording on YouTube available for you guys. And you all will get an email with that link, as well as a link to this presentation that Adrian has shared with us, which also has the GitHub repo in there.
Well, and maybe one last thing I'll say, we're just getting started with the summer camp here. So this is week 2 out of 9. We have a whole lineup of other speakers who are going to be joining us for a variety of other topics. So if you're on this call, that means you've already signed up. So you'll get those invites soon if you haven't already. But yeah, please stay tuned for more sessions.